Welcome to the Ductile series of architectural technology instructionals. In this introductory instructional, we will cover some of the basic concepts and design thinking required when working with steel. Steel is a brilliant material for expressive and light and effortless construction. It can do almost gravity-defying feats that timber and concrete cannot do. In this example from Enric Morales in Barcelona, the Avenue de Icaria, we can see a composite of steel elements that have been configured into quite an organic and expressive shade structure. Similarly, closer to home with the arbour at the South Bank parklands, this structure has quite a deal of complexity, but surprising just a limited number of standardised components that have been configured in different ways to create the family of shapes that you see. Now, steel is one of those structure types and constructions that is very well suited to digital fabrication. It is a very precise and stable material, and CNC technology, including plate cutting, water jet cutting, plasma cutting, and automatic welding, have meant that the available repertoire of forms is actually quite broad. And there's the lightness factor as well, and particularly in tropical climates where shade and weathering is important, steel has a very central role to play. The important thing though with steel is that it is essentially a prefabricated system. It is very difficult to work the material on site, and it's the remit of the architect to make sure that the way the steel elements come together is very thoroughly thought of beforehand. Here we can see a shade structure situated at the St Lucia campus of the University of Queensland, and we can see the connections at the junctions, which are very neat, very well done. They're all bolted connections, but they're very well considered so that the elements come to a single point. The same can be seen in the Hawken Engineering building, though steel this time is used in a slightly different way, and I guess a little bit more common, where standardized profiles or components are reconfigured and combined to make unique assemblies. In this sense, in this example, we see a series of bowstring trusses that are fabricated up from simple equal angles, some of which have been pre-bent. And the way that the elements all come together, particularly the cruciform configuration of the columns and the way that they lend themselves to sleeving in different cleats and so on, means that the whole system is thought very three-dimensionally and very elegantly and easily put together. The other main thing that metal is used for the sort of secondary and tertiary elements of a building, in this case the decorative screens. So we have both perforated flat metal as well as expanded metal, both offering a wide range of aesthetic potential and colour. Both and in terms of the aesthetic potential, there is the capacity to moderate both the pattern and the pitch of the perforation to make the building skin appear more or less transparent. And secondary things like balustrades and so on, which, although are not primary steel structural elements, are nonetheless very important because they form almost like the jewellery to a building, and something you come in contact with quite frequently because it is at the sort of scale of the human interacting with the edges of the buildings. It's important to try and get these elements right. They do make an aesthetic event in the building, and it is possible to make it either too fussy, and very simple detailing mistakes can become very visible. And in balustrades in particular, because typically there's quite a lot of it, and it needs to sort of fit in between a system that's perhaps not as precise, like a concrete or a masonry building, the precision element inserted into a non-precision system needs to have a degree of flexibility, and often you'll see balustrades broken down into elemental pieces with an allowance between the different panels to account for some tolerance in the installation. Well, that completes the first of the ductile series. Please stick around. There's another set of videos to come where we'll cover some more of the technical aspects of the material. Thanks again for listening.